Okay, let's solve another problem on bending moment and shear force diagram. So write down the problem. Draw the BMD and SFD of a simply supported beam with point load and UDL of WDL and UDL as shown in figure. The problem is draw the bending moment and shear force diagram of a simply supported beam with point load and UDL as shown in figure. So let's draw the figure. First, draw the diagram. So, there is a simply supported beam AB with point load at B and a UDL in between B and C. Length is your 2 meter, and 4 meter. Okay. So, BC part is your 4 meter, CT part 2 meter, and AD part 2 meter. So, whole length of the beam is 8 meter. You have to draw the bending moment and shear force diagram of the beam. So, for this, first we have to draw the bending moment. We have to draw the free body diagram. So, let's draw the free body diagram. Here in full diagram, I am just removing the support A and B and using support reaction VA and VB and HA at support A and B. So remove this hinge support and put HA is equal to 0 and PA here at B to vertical reaction or vertical support reaction VB. This is your A point, B. Okay. Now, first step calculation of support reactions. Solution. Now, in equilibrium, summation of horizontal force is 0. So that means H is equal to 0. Next, apply second condition. Summation of vertical force is equal to 0. So, summation of G is equal to 0. That means VA plus VB. There are vertical force 40 kN and UDL. Total UDL 10 into 4. So, These two vertical external force acting vertically downwards and support reaction acting vertically upwards. So minus point load 40 minus UBI for 10 into 4, 10 into 4, total 0. So from this you can write VA plus VB समान 80 equation number 1. Okay? Then the second condition, moment. If take moment about A is equal to 0, then taking moment about A, sum of A in at A and plus is equal to 0. Then the equation becomes vertical force VB, due to VB, moment will be anti-clockwise. So before that, let's know sign convention. Plus signing positive, coming negative. So this is the sign convention. No, sign convention of shear force and movement. Sign convention plus sign convention. Now for the moment about A, GB into 2 plus 4 means 8. So GB into 8 anti-clockwise, and for these two vertical force 40 and 10 UDL. This makes clockwise moment. So minus. So 40 into 2 meter. This is 2 meter. So let's draw simplicity. 2 meter, 4 meter. Minus for 42 Newton point load, moment becomes 40 into 2. 40 into 2. For this UDL, force is 40 into 4. And distance is your, for this UDL, the resultant of this UDL will add to its CG, ED. That means 4 by 2 distance. So the distance between A and this CG is your 2 plus 4 by 2. So the distance becomes 2 plus 4 by 2. So this is the equation. Now from this equation you can calculate dB. Now calculate this. Probably 40. Please calculate probably 40. And check someone. Now put dB is equal to 40 km in equation 1. Then your VA plus 40 is equal to 80. That means VA समान 40 also. So VB is equal to 40 km and V is equal to also 40 km. Please check. VB is 40. Okay. Then VA is also 40. Okay. Now our next step is, what is the next step? Bending moment or BM calculation. So shall I erase this portion? Now bending moment calculation or BM calculation. BM calculation. Bending calculation or BM calculation, whatever. First write sign convention. the sign convention of bending moment and shear force. This is called N, this is called N. Now, very simple. Now, in this case, I will not take any section. I will just put important point. I will calculate the moments at main points, at different points. Okay. And I will calculate moments at A, B, C, D. It's simple. Bending moment. Moment at B. How much? M is equal to how much? Moment at B 0. Roller support. Similarly, bending moment at A. MA. How much? Hinge support. Hinge support. Now, moment at C. Bending moment at C is your MC. For this, what you have to do? You have to stand at C and you have to do either A or either B. I will suggest look towards B because two reactions, two forces, 1, 2. There is also 2, but and I will suggest you just look towards B. So for MC, how many vertical forces are there? When we are calculating moment at C and looking towards B, how many vertical forces are there? DB and DBL. So for DB calculate moment, DB into 4 meter. You are standing here, standing at C, looking towards B. So vertical force DB into 4 meter. That is moment DB into 4. And this makes clockwise and anti-clockwise rotation. Anti-clockwise means this one plus DB 4 here, and this for this UDL. It creates clockwise moment minus how much force first? Minus 10 into 4. That is load, UDL load, and its CG distance, and this UDL acts to its CG. That means how much distance from C? 4 by 2. Isn't it? 4 by 2. This UDL acts to its CG. That means total length 4. So middle means 4 by 2. This into 4 by 2. 0. This is equal to 0. Sorry, not equal to 0. This is the total moment. Total moment. So MC becomes how much? dB to be 40. 40 into 4 minus 80. So it becomes 80. 80 kilonewton into moment equation. In the moment, force into distance. This force Newton, distance meter. This is the moment at C. Now calculate moment at D. Bending moment at D. So while calculating bending moment at D, what you have to do? First, you have to stand at D. Then you have to look either towards B or towards A. Then which side will you prefer? A. Okay. Now you stand here, look towards A. Stand here, look towards A. So A, B. How much? Right? Only one vertical force. Only one vertical force. Only VA. So what will be the value of moment? VA into B into 2. Let's say VA into 2 plus or minus. That's next. Clockwise rotation. Plus. Okay, nothing. Plus. That means 40 into 80. Okay. So now let's draw the bending moment diagram. Very simple. Now at B moment is your 0. At A moment is 0 at C. Moment is how much? C, 80. So let us say this value is your, okay? Now I am not discussing about D. Okay, I'll do it. Okay. Now, how to join B and C? A, B, C, D. How to join at point D or at support D? Moment is 0 at point C. Moment is 80. Now, how we will join A, B and C point? Parabolic. Because UDL is there. If I take the section at distance x square terms will come. So then we will join these two points with the help of a parabolic curve. Clear? Parabolic curve. Listen to. Now let's think about D. How much moment at D? 8. Same value? Same value 80. Now how to join A and B? The straight line. Triangle, straight line. X रेखा था. Basically X रेखा. If I take X, moment is V into X. So join these two points by a straight line. It looks like triangle. Now moment at D is 80 km. Moment at C is also 80 km. Now how to join D and C? Simply straight line. Very simple. It's straight line. Because here is, if you see from here, there is two. If you stand here, just stand here. You see two vertical. You stand here, two vertical. BA and 40. If you stand here, looks like this side. Again, BA 40. Point low. Always point low. So join by straight line, not by curved line. So simply join. This is your bending moment diagram. That's right, parabolic. Parabolic straight line. Am I clear to everyone? I think there is no problem. So, anyone have any questions regarding this diagram? You can ask. If you say, sir, I'm asking to point load towards left side. If we stand here and looks towards B or right side, then there is UDL load. When UDL load is in from here, to take, just think. If you take a section XX here from this distance. Suppose your x distance, and say moment is here how much? Just think. Because here if you stand here, look this side, from this UDL, in the equation of moment, only x square term will not come. Only x term will come because here total load becomes WL instead of WX. Total load WL into moment how much? WL into X. X এর এক ঘাত আসবে। যখনই এখানে থাকবো তখন x এর 2 ঘাত। এখানে থাকলে 2 ঘাত। তখন x হয়ে গেল 2 ঘাত থাকলো। যখনই এখানে চলে যাব 1 ঘাত। কারণ একটা x এর জায়গায় L বসে যাবে বা L বাই L বসে যাবে। এখানে 4 বসে যাবে। যখনই UDLটা বেরিয়ে যাব তখন সেটার জন্য এক ঘাতই আসবে। UDL মধ্যে থাকলে বেসিক্যালি প্যারাবোলিক হবে। ওই জন্য এই পার্টটা প্যারাবোলিক করেছিলাম। তখন এখান থেকে শুরু করছি স্ট্রেট লাইন করে দিচ্ছি। UDL এটা খুব মনে রাখার জিনিস। তাহলে এদিকে দেখছি পয়েন্ট লো, আবার এদিকে দেখছি UDL, তাহলে তো UDL প্যারাবোলা হতে পারবে। কেন হবে না? UDL এর মধ্যবর্তী জায়গাতেই একমাত্র প্যারাবোলা হবে। বাকি জায়গায় যা লোডটা আছে সেটা হবে। কারণ এখানে UDLটাও একটা কনসেন্ট্রেটেড লোডের মতো কাজ করবে। কারণ পুরোটা UDL, পুরোটা W আর X থাকছে না। যখন লোড বলছি পার্সিয়ালি হলে WX, ফুল হয়ে গেলে তো WL, আর L তো কনস্ট্যান্ট, ভ্যালু দেওয়া আছে তো। তখন কি সেটা কনস্ট্যান্ট নয়, ভ্যারিয়েবল না। ঠিক আছে? Okay, so these are all about bending moment diagram. Now Next step is your shear force calculation. Next step, shear force calculation. Okay. Now next step, shear force calculation. On shape calculation or shear force calculation. Very simple. Now calculate shear force at B. A shape at B. How much? Total shear force at B. Shear force at B. बोलो दाड़िए किसी को वर्टिकल फोर्स कितने तो दाड़िए कितने दाड़िए वर्टिकल फोर्स कितने तो बच्चों B nothing but at B shear force is only B plus or minus vertically upward. What means minus 40 kilonewton. Similarly shear force at C. At A first shear force at A shape at A plus VA plus B shear force at A only here plus VA this one plus 40 K. Then shear force at D or D whatever at D is your just calculate the shear force at D. Please stand here and look towards A. Only two vertical forces DB and 40 terminal. Clear? So let's write plus VA minus 40 becomes plus 40 minus 40 becomes 0. Now shear force at at C, what you will see? Look towards B. So minus EB plus UDL part minus calculate the shear force at C. You can stand here. Look towards B or towards either towards D or towards A. Okay, let's look towards B. So BB plus how much UDL? How much UDL? 10 into 4. 10 into 4. So minus 40 plus 40. Comes 0. Now let's draw the shear force diagram. Now shear force at B. How much? Minus 40. So go towards. This is your minus 40. Here shear force at A plus 40. So go up plus 40. Shear force at C. How much? 0. Just like this. At D. 0. Now how you will join? How to join B and C? Anyone? Triangle. Because UDL basically what? Triangle shear force. Let's join like this. Okay. Now how to join? At A shear force 40 K, at D shear force 0. Then how to join A and D? Constant rectangle. That means you see here shear force is your VA. Here is also VA. Here is also VA. But here VA minus 40. So this constant again up to 0. At point C, shear force 0. At point D, shear force 0. And like this. This is nothing but your shear force. Is a plus minus. Is it not easy to draw? So this is the Shear diagram. Okay, anyone have any questions?